I welcome you all for this presentation. In this presentation, we are going to discuss about substitution techniques. Here I have given two because this is the continuation of the previous lecture. In this presentation, we are going to discuss about the monoalphabetic ciphers, security analysis of monoalphabetic ciphers. Then we are going to discuss some example related to monoalphabetic ciphers. Then next substitution cipher is the Playfair cipher. Then we are going to analyze the security of the Playfair cipher. Then we are going to solve some problems related to Playfair cipher. Also, I have given you some problems as homework, followed by summary of this presentation. Next substitution cipher is the monoalphabetic cipher. In the previous lecture, we have seen about the Ciphers cipher. It is the very base substitution cipher. It is also called a shift cipher. Here, rather than just shifting the alphabet, that is in the Ciphers cipher, we just shifted the alphabet. In monoalphabetic cipher, what we are doing is we are shuffling or permitting the letters arbitrarily. So here each plain text letter maps to a different random ciphertext letter. So what is the disadvantage of Caesar cipher means if you find out say for example key is 3 means we know that from D it starts on. So next position it just shifts up. We know easily we can find out. If we find the key we can easily find out. At least for one letter if you find means also we can easily find out what is the key and we can easily break the crypto system. But in order to overcome that, there is a delta improvement in the security aspect in this monoalphabetic cipher is instead of just shifting, we are just shuffling the alphabets. So here the key size is 26 letters only and each plain text letter maps to a different random ciphertext letter. See here, the plain text is given as A to Z and the ciphertext it is shuffled. For A it is D and for B it is K. It is shuffled. Not there is any sequence or continuity is there. It is just shuffled. That's it. So the plain text, if we wish to replace letters, for if I it is W, so it is replaced by W. For F it is I, so it is replaced by I. Likewise it goes on. So here we can improve the security to some percentage compared to Caesar cipher. So by analyzing the security of this monoalphabetic cipher, now the key size is increased to 26 characters. So we are having 26 factorial different combination and I am giving you all one plain text and I asked you to use monoalphabetic cipher. Each one of your key is different because you are not discussing with others or you are not using any technique what others are using. Simply randomly if you are shuffling means you are getting different ciphertext only. So we feel that totally 26 factorial keys are there. So with so many keys we might think that it is very secure enough. But that is not correct. It is wrong because it is based on the language characteristics. Language characteristics in the sense in English some frequently arising characters are there. So if we find the frequently arising characters and for the frequently arriving characters we just replace any of the character, then we can easily find out. If we succeed in that, we can easily find out. Let us see that. So here language redundancy and cryptanalysis. Generally human languages are redundant. That is in English TH, then LR, DS, M, shepherd, shall not, wend. So if you find something like this means we can easily, the Lord, something we can easily guess, right? Some letters we find out means. So letters are not equally commonly used and English E is by the far most common letter. You see here E, it is 12.702%. A it is 8.167%. T it is 9.056%. So the letters, most common letters are E, T, R, N, I, O, A and S. And rarely used letters are Z, J, K, Q, X. See here for Z it is 0.074%. So it is rarely occurring letter. So various languages have tables of single, double and triple letter frequencies. If you take any letter paragraph, the word "the" is occurring frequently. So if you find the related letter for T, H and E, we can easily find out. So remaining only we have to find out. So it is very easy to break this crypto system. So the key concept is monoalphabetic substitution ciphers do not change relative letter frequencies. It was discovered by Arabian scientists in 9th century. See how old was it? And it calculates letter frequencies for ciphertext. Here we can compare, can count, plot against the known values. So if Caesar cipher look for common peaks or trucks, that is peaks means AEI triple, NO pair, RST triple, all those things. Troughs means JK, UV, W, X, Y, Z. And Caesar cipher look for this common peaks and troughs. Monoalphabetic must identify each letter. So that is tables of common double, triple letters will help, and diagrams are there, and is all those things are frequently occurring. So if we find those characters, we can easily break the crypto system. So amount of ciphertext is important. That is, the statistics plays a vital role in this type of cipher. See, we can see one example here. On ciphertext is given. So how the attacker is breaking the crypto system means the attacker is guessing for P and Z and succeeded like E and T. And for ZW, it is TH. So ZWP means it is meaning is that. So proceeding with the trial and error, finally the attacker break the crypto system, and the message was disclosed. We can see it was disclosed yesterday that several informal but direct contacts have been made with political representatives of the White Congress in Moscow. So mostly these ciphers are used in military and world wars and all. So and the informations are like this. Next cipher is Playfair Cipher. So far we have learned Caesar cipher, it is a shift cipher, and another one is the monoalphabetic cipher. So there we consider a single character only. So if you want to improve the security, if you consider more characters, then the cipher may be somewhat more secure. So here one approach to improve the security was to encrypt multiple letters. For that we are having example Playfair Cipher. It was invented by Charles Wheatstone in 1854, but he named after his friend Baron Playfair only as Playfair Cipher. And in the Playfair cipher, what we have to do is we have to construct a Playfair matrix. It is a 5 cross 5 matrix of letters based on the keyword. 5 cross 5 in the sense we are having only 25 cells only, but we are having 26 alphabets are there. So what we have to do, we have to merge this I and J. Wherever I is coming, there you have to put a slash and you have to put J. So first you have to fill all the letters in the keyword by removing the duplicates. Then we have to fill the rest of the matrix with the other letters. So that we are getting a Playfair matrix. It is a size is 5 cross 5. Then once the Playfair matrix is ready, we have to perform encryption as well as decryption. So the plaintext is encrypted 2 letters at a time here. So if a pair is a repeated letter, then we have to insert a filler like X. And if both letters fall in the same row, then we have to replace each with the letter to the right. That is wrapping back to start from end. And if both letters fall in the same column, then we have to replace each with the letter below it. That is wrapping to top from bottom. Otherwise, each letter is replaced by the letter in the same row and in the column of the other letter of the pair. So we have to form a box, then we have to find out the letter in the same row and the other letter in that pair in the column. So ciphertext is decrypted 2 letters at a time with the reverse process of the encryption. Let us see one example for this Playfair cipher. Here you can see the message, that is plain text is move forward. So what is the first step? We have to divide it into pairs. So MO, VE, then FO, RW, AR, D, we are having a single letter. So we have to fill some filler X. Here X is just a filler, message is padded and segmented. Then we can apply the rule. So MO, for MO you see it is occurring in the same row. Same row means you have to see the right. For M it is O and for O it is N. So ON. Then VE, V is here and E is here. So you have to form a box and other side we have to check. For V it is U and for E it is F. So we are having UF. Then FO, F is here and O is here. They are coming in the same column. So below we have to see for F it is P and O it is H. So PH. Then RW. Where is R? Here R is there and W is there. So we have to form a box like structure RW. So for R it is N. N we are having. And for W we have to choose Z. Then AR it is falling in the same row only. So we have to do wrap around. For A it is R and for R it is M. So RM. DZ, D and X, DX. So we have to put a box here. And for D it is B and for X it is Z. So BZ. So the ciphertext we got us this one for the message move forward. So this way only we have to use the Playfair cipher to perform encryption. So if time permits, you please try for the reverse process, that is decryption is the reverse of the encryption. You please try it. So coming to the security analysis of this Playfair cipher, the security is much improved compared to the monoalphabetic cipher, because here we are having 26 cross 26 equal to 676 diagrams are there, and we need a 676 entry frequency table to analyze. That is we are having 676 frequency table, but in the monoalphabetic we have only 26, and correspondingly more ciphertext is also there, and it was widely used for many years because it was somewhat secure compared to monoalphabetic and Ciphers, so it was used many years, and it was mainly used by the US British military in World War I and II. It can be broken given a few hundred letters, since still has much of plain text structure. So it is also vulnerable to some attacks. So the attacker can break the cipher also. So we can in the next class we will be seeing some other substitution techniques that is giving more security compared to this Playfair. Here I have given you 3 practice problems, and in the free time you try to solve these problems. First problem, you have to construct a Playfair matrix with the key decryption, and the second one you have to construct a Playfair matrix with the key largest. And third is you have to perform encryption with whatever the constructed Playfair matrix in 1 and 2. So in this presentation we discuss about monoalphabetic ciphers with security analysis and example, then Playfair cipher with security analysis and example, and I have given you 3 problems to practice. In the next presentation, we will be discussing some other substitution techniques. Thank you.